All right, you're back. So we have right now a infinite series that is going to be equal to 1 over 1 minus x, but only for the case where the absolute value of x is less than 1. This right here, incidentally, is called the radius of convergence. And we can speak about the interval of convergence, which you saw in your calculator, which is that interval from -1 to 1, since we're centered at x equals 0, on which this is actually true. For those of you that are kind of interested in thinking about the endpoints here, which we often want to test, clearly if we use x equals 1, so in the x equals 1 case, this becomes that, which is clearly a divergent series which goes to infinity, which kind of makes sense based on that. The interesting thing, I think, is testing the case where x equals -1, which we've certainly looked at a lot in my class. So this is the case of 1 minus 1 plus 1 minus 1 plus all the way to infinity, which again is a divergent series, but here's a little bit more evidence that perhaps we can trust that proof that that infinite divergent series actually somehow equals 1/2. But if you hate that, just ignore me. So the interval of convergence is just from -1 to 1 at the endpoints. Those are divergent series, so we're not going to use those. The other thing now, so given that we have a polynomial representation of 1 over 1 minus x, we can now use this as a structure to maybe derive some other forms of series. So for instance, if I want to now find this, you think for a second about what you might plug in order to use this structure to make that. Well, clearly, this is just a form of that series, or of that fraction, where x is equal, or I guess where we plug in -x in place of x. So this is 1 minus -x here. And so if I now go up here and replace each x value with a -x, I've actually to some extent derived a new series in which I can say that 1 over 1 plus x is equal to 1 minus x, still going to stay plus x squared, then minus x cubed plus, and that can go on to infinity as well. So I've got that alternating. If you think about the interval of convergence for this as well, though, now I need the absolute value of -x to be between -1 and 1, so same interval of convergence as we had before. One further thing that we'll do some more lessons on shortly is, now that I have a polynomial representation here, can I think about doing some calculus tricks in terms of integration or differentiation in order to derive something else? So you all know how to take the integral of 1 over 1 plus x. If I do the same thing on the other side, so take a second to just think about what that's going to equal. So this is going to be, so now I'm going to integrate this as x minus x squared over 2 plus x cubed over 3 minus et cetera, et cetera, et cetera. And this now is a new power series that you have for a natural log. So we had seen sine of x, we had seen cosine of x, we had seen e to the x. Now you've got one for natural log of 1 plus x. Great spending some time with you.